Part 2 of solving trig equations. So let's take a look at number 6 right here. We're going to use a little bit of a trick right here. We want to always get sine and cosine to be the same. We can't have them be different when you're trying to solve it. So we're going to convert the right side in terms of sine. To do that, we're going to use a Pythagorean. We know we get sine squared of x plus cosine squared of x. We know that equals 1. So that if I solve for cosine of x, we're going to get 1 minus the sine squared of x. So if I rewrite this, I'm going to get the sine of x plus 1 equals the square root of 1 minus the sine squared of x. Now I have them in terms of sine, and I like that. Whatever the cost, you got to get that. Next, what we have to do is we have to get rid of the square root. Well, what gets rid of square roots? Squaring both sides. And if I square the right side, that's easy. It just gets rid of my square root. But if I square the right side, please be careful. This is not sine squared of x plus 1. This is sine of x plus 1 times sine of x plus 1. We get sine squared of x plus 2 sine of x plus 1. Combining your like terms, bring your sine squared of x over. I get 2 sine squared of x plus 2 sine of x. Look at this. The ones cancel. It equals 0. We want that equal to 0. So you guessed it. What do we do next? Yeah, we factor. They both have a 2 and a sine. 2 sine of x, that's going to give me sine of x plus 1 equal to 0. And using the zero product property, sine of x equals 0 for this one, and over here, sine of x equals negative 1. And we should know this. Where does sine equal 0, but at 0 and pi? Remember, we don't include 2 pi because we're limiting ourselves to 0 and 2 pi, but 2 pi is not inclusive. Where is x equal to negative? Sine equal to negative 1? You got it. 3 pi over 2. Very good. All right, now, number 7 is kind of a tricky one right here. We got this 2x right here. Now, we're going to talk about that. That means you can actually go around the circle twice. And that's kind of a tricky one to do because we're actually going to double our quadrants. Normally, we go from 1 to 4, but now we can go from quadrants 1 to 8. And you'll see what we mean by that in a second here. Okay? Now, if I solve it, just like normal, bring the root 3 over 2 over. And I solve like normal, my reference angle. Reference angle, ignore the 2 for now. My reference angle is where does sine equal square root of 3 over 2. Now that's easy enough to do. That's pi over 3. So here's what we have to talk about. The angles. We know it's positive in the first and second quadrant. In the first quadrant, it's going to be pi over 3. In the second quadrant, it's of course going to be 2 pi over 3. But you got to be careful. Because of the 2x, we're going to have to go around twice. We're going to go around the circle one more time. This means go around twice. Go around twice. That's what that means. I have to go around the circle twice. So if I'm in the first quadrant, if I go around, there's one time. I went around one time. If I go around twice, I have to add 2 pi. So my next theta for this quadrant, if I add 2 pi to here, what's that? That's 7 pi over 3. You can verify the math. In the second quadrant, if I add 2 pi, that's going to give us, what's that? 8 pi over 3. So here's are my reference angles. So those are my angles. But we're not done yet. That's just our quadrantal angles. Now we actually really have to solve it. Normally it would be, we're done. But the 2 messes us up. So what we're going to do here is we're going to write 2x equals. And we're going to name all of these angles. Pi over 3, 2 pi over 3, 7 pi over 3, 8 pi over 3. And we're going to do one more step to solve it. And we're going to divide everything by 2. This becomes pi over 6. Here we get 2 pi over 6, which just becomes pi over 3. Here we get 7 pi over 6. And here we get 8 pi over 6, which is just 4 pi over 3. Now there is a pattern to them. Most people just remember the pattern, okay? But it takes a while to get used to it. Try number 7 one more time, and then what I would like you to try is number 8. And we'll go over this in class tomorrow, okay? But be careful, instead of dividing by 2, we're going to multiply by 2. But also, we don't go around a full circle. We only go around half a rotation, rotation there. Kind of cool problem there. All right. Number 9, easy enough to do. Bring the 6 over. So you got tangent squared of x plus 5 tangent. See, I got them all the same term. I like that. But because of the square, it must equal 0. Must equal 0. So we get the 4 tangent squared of x plus the 5 tangent of x minus 6 equals 0. And again, if you don't like it, rewrite it. Use x's. That's okay. And I can factor this. Now, however you factor is however you factor, okay? But you got to factor this problem. This gives us 4x plus 3 minus 3, there we go, and that's going to give me x plus 2 equal to 0. And then to finish up on this one, remember, this becomes x equals 3 over 4, x equals negative 2. And we're doing, of course, tangent. Okay, we're doing tangent. So we get the tangent of x equals 3 over 4. The tangent of x equals negative 2. So I asked myself, now for these ones we'll probably have to use a calculator to solve, so let's go ahead and grab a calculator for this one. Where does tangent equal 3/4? Remember, tangent is positive in the first and third quadrant. So if I use my calculator, see, unfortunately we don't know this value. It's not a known value for us. So remember, make sure you're in the right mode. Radian, I like radian. Second, tangent, and I just type it in. 3 over 4. 3 divided by 4. And I get 0.64. That's my reference angle. So that's my first quadrant. 0.64. Remember, to get the second quadrant angle, or the third quadrant, we take pi plus 0.64. So if I take pi, 3.14 plus 0.64, we get 3.78. Where is tangent equal to negative 2? Remember, we're in quadrants 2 and 4 here. So my reference angle, remember the calculator is going to give me my reference angle, second tangent, negative 2. It could be negative 1.1107. I make it positive just so I can keep, just so I can make sure I get the right angle here. So my reference angle here is 1.107. So to get the second quadrant, okay, so you get the second quadrant, quadrant 2, remember it's going to be pi minus 1.107. So if we do that in the calculator, 3.14 minus 1.107, I get 2.033. And then to get the fourth quadrant, we do 2 pi minus the reference angle. 2 times 3.14 minus 1.107, and I get 5.173. Alright, what I would do, definitely work these again, okay, and we'll go over these some questions tomorrow if you have any. Feel free to ask questions. We're going to practice these for 2 days, okay? Thank you. Bye-bye.